factor. You know, while reading the Bragg diffraction, you have read that the atoms inside a crystal acts like identical scatterers. Okay. Now, when some radiation, this radiation may be anything, it may be some X-ray, some electron beam, or maybe some neutron beam also, you know. So, when this incident radiation falls on the crystals, then these atoms reflect it. This is known as a Bragg reflection. Okay. Now, it will depend upon these atoms and some factors, which is known as the structure factor. This factor will just quantify how much these atoms are basically scattering the radiation. Okay, the quantitative measure is given by this structure factor, and depending on the orientation and the atoms in the basis and several other factors, you will get some interference pattern. It may be constructive, which is corresponding to some allowed reflection, and it may be destructive also, which is corresponding to some forbidden reflections also. So, this structure factor is denoted by mathematically by a factor f, which is equals to sum over I will be from 1 to n. This denotes the number of atoms per unit cell. So, this summation is extending over the atoms inside a unit cell. The formula is f of I e to the power twice pi I into h e y plus k v I. So, I am just removing this one for the time being, plus L W I. So, these H, K, L are the Miller indices, U I, V I, W I are the atom positions, the coordinates of the atoms, which you have taken I equals to 1 to n. Let us say n number of atoms are there in the unit cell. So, these are the coordinates of those atoms U I, V I and W I, and F is known as the atomic scattering factor. This will depend upon the nature of the atoms. If let us say it is sodium atom, then its factor will be something. If it is a chlorine atom, its factor will be something. Now, let us say in a unit cell there are identical atoms. So, for identical atoms, the value of F will be same for all of them. Consider a simple cubic monoatomic Bravais lattice. Simple cubic monoatomic Bravais lattice you are given, which has a basis with vectors. One vector R1 is equals to 0, R2 is equals to a by 4 x cap plus y cap plus z cap. So, as I told you, I was extending from 1 to n. So, I is 1 and 2 basically 1, 2. 1 is this is the Poisson vector of the first atom, and this is the Poisson vector of the second atom. So, you got UVW for both the atoms. The Bragg reflection is observed due to the change in the wave vector between the incident and the scattered beam, as given by k is equals to n1 g1 plus n2 g2 plus n3 g3. So, here you see this n1, n2, n3, these are equivalent to h, k, l values. So, we can easily put it that into the formula. G1, G2, G3 are the primitive reciprocal lattice vector. For n1 is equals to 3, n2 is equals to 3 and n3 is equals to 2. What will be the value of the geometrical structure factor? So, these values are given. N1 is equals to 3, N2 is equals to 3, N3 is equals to 2. Now, you see there is no mention about the F factor or the geometrical or atomic scattering factor is not mentioned. So, for the timing we can just ignore that. Okay, we can just take the value of F to be 1. So, let us apply this here. So, let us remember a by 4 x cap y plus y cap plus z cap. Okay, so let us apply the formula of the structure factor. So, S will become the structure factor S, which is a function of let us say n1, n2, n3. So, we are just doing some modification in the formula as per this, because in place of HKL we have n1, n2, n3 now. So, we can write exponential 2 pi let us say I into, let's say, xj n1 plus yj into plus zk, okay, zj n3. Now for the first atom, this x, y, g are 0, so this becomes exponential 0 is 1 plus this is exponential 2 pi I x1, x2, x3, a by 4, a by 4, a by 4. So we can just take 1 by 4 and n1 into n3, this is given 3, 3 and 2. So this becomes 3 by 4, 3 by 4 and 2 by 4. So this will become like this. So this is equals to 1 plus exponential 6, 8, 8 by 4, 2, so 4 pi I, ऐसे आएगा ना, this is 4 pi I, yes. And what is this value? This value is 1, so 1 plus 1, 2. So the factor is coming out to be 2. So in this way you can handle these problems from structure factor. The atom position in the basis will be given to you, or the atom position in the unit cell will be given to you, and here you see the, if nothing is mentioned, you can take the atomic scattering factor to be 1, and if it is mentioned then you will take it accordingly. So you have to remember that original formula, and using that you can easily solve problem based on structure factor. I hope you find this video useful. If you are new to this channel, please subscribe the channel and don't forget to press the bell icon. Finally, thanks for watching.